Okay, I'd just like to take this moment to thank Mr. Portala and all staff for the international organization of this virtual conference. They have been always ready to accept my request. One moment, please, because, okay.
Yeah, we lost your slides. So you have good time.
Because the presentation goes on since I put on my PC. I don't know why. Okay, the presentation deals with reusing of some specific waste for making hot and cold asphalt mixtures, specifically jet grouting waste and reclaimed asphalt pavement for base layers. So just a few words on road laboratory, Luigi Tocchetti at the University of Naples, where me and my colleagues work. I don't know why it's go on since I push. Okay, so on the left side, you can see the entry of the laboratory, and on the right side, you can see the main buildings of University of Naples. So you can see here the main materials that we investigate. On the left side, you can see traditional materials that are limestone aggregates, filler, basalt aggregates, and on the right side, you can see waste like gridded plastic containers, like, for example, gridded plastic bottles, municipal solid waste from incinerators, milled old existing pavements, and last but not least, jet grouting waste. So the laboratory covers almost 500 meters squared, and 5 main rooms can be identified. First one, on the left side, you can see the offsetting materials room, and on the right side, you can see, I don't know why it goes on, and on the right side, you can see the meeting rooms. This is the main room where we carry on tests on bitumen and on mastics. And that is the room where we investigated asphalt mixtures, cold and hot solutions. On the black circles, you can see the main equipment that we have. And this is the last room where we test on-site mixtures. So the main goal of this presentation is to compare 3 asphalt mixtures for road asphalt pavement base layer that match standard requirements, in particular specific technical requirements in the southern Italy. We have compared 3 main solutions. The first solution concerned the hot mix asphalt by using limestone aggregates filler. The second solution refers to hot mix asphalt containing jet grouting waste in complete substitution of natural limestone filler compared to the grading curve of the previous mixtures. And the third solution refers to the cold recycling of milled asphalt pavements, adding jet grouting waste as a filler. The jet grouting waste was grinded and sieved for its reusing, while reclaimed asphalt pavement was used as it is as a result of the milling process. We have 2 main goals. We would like to reuse jet grouting waste for making hot asphalt mixtures, and we would like to combine 2 types of waste, jet grouting waste and reclaimed asphalt pavement for making cold asphalt mixtures. Just one clarification. To date, we don't have a well-defined procedure for cold recycling of milled road asphalt mixtures in Italy, unlike hot recycling that relies on more consolidated procedures. So jet grouting waste here used derived from soil consolidation activities. In particular, in Italy is recognized the use of jet grouting waste, but just for concrete grout and for foundation or sub-base of road embankments, after be subjected to environmental compatibility analysis. You can see on the left side, you can see on the bottom left side, the solidified particles of jet grouting waste that we have used. And on the bottom right side, the result of the grading process, because the materials was subjected to a laboratory grading process by adopting a ball mill for 2 hours, almost, after which no significant variation we have observed in the final grading sites. So, jet grouting waste and reclaimed asphalt pavement were subjected to a leaching test. We don't have in the road laboratory equipment to carry out tests. And so the procedure was carried out by a certified chemical laboratory. 2 main steps can be mentioned. The samples were prepared in compliance with an international standard, and the leaching test was conducted at the 20 plus minus 500 degree. Results, as you can see on the right side of the feature, emphasize how jet grouting waste in green bars in the graph and RAP in the gray bars into the graph don't exceed the environmental requirements fixed by Italian ministerial decree, and they may be used as aggregate in the road bituminous mixtures. So jet grouting waste match filler property, as you can see in compliance with AN 1097 standard, because all material passed to sieve equals to 2 millimeters. The wrap were used derived from the milling stock peeled process of all the wearing course binder layers, and it was used as blade rock. It means that the solidified bitumen that covered the aggregate and helped to make a bound structure aggregate was not reactivated by rejuvenators. The grading curve of the wrap, as you can see on the right side of the graph, needed to be correct because it does not perfectly match standard. And so we have added the limestone aggregate to match standard, as you can see. The main property of the wrap we are investigated are shown in the table on the bottom of the slide. So, second step of the research focus on the mixed design of the 3 mentioned mixtures. Firstly, we have investigated the hot traditional solution made up by using only limestone and filler aggregates. And we have designed the second solution that included the jet grouting waste as a filler in a complete substitution of limestone filler. In particular, for the core recycling asphalt mixtures, we have used the 4% of jet grouting waste as a filler and huge amount of reclaimed asphalt pavement. As you can see on the figure on the right side, you can see the grading curve of the hot mixtures, in particular traditional and innovative hot asphalt mixtures, where we have used jet grouting waste in pink color, and the cold recycling of mixtures in red color. So the grading curve of cold recycling asphalt mixtures consists of 70 almost of RAP, 4% of jet grouting waste, and 20% of limestone aggregates. Next step focused on the identification of the best bitumen content, that is the binder of the hot mixtures. In particular, we have used a net 57 net bitumen, whose properties are shown in the table, as you can see in the slide. Specifically, we have used a cylindrical specimen with a diameter of 150 millimeters, prepare a 170 Celsius degree under a gyratory compactors, as you can see on the right side. And we have compacted specimen at 180 number or revolution to reach a desired property, such as, for example, thickness, hair oil contents, and density, in line with a specific tender specification. So we have investigated bitumen from 3 to 5% by the total weight of the aggregates, and best percentage of bitumen was 3.8% by the total weight of the aggregate for traditional hot-mix asphalt. But when we have reused jet grouting waste as a filler in complete substitution of the limestone aggregate, the percentage of the bitumen increased, and it's in line with the Regent Boyle's value. This is important because the Regent Boyle's reflects the percentage of intergranular voids filled by bitumen. So, referring to the cold recycling of the whole milled asphalt mixtures, we have replaced, as a no in the literature, bitumen with bituminous emulsions, and we needed Portland cement. The bituminous emulsions composed of 6% of SBS modified bitumen and 4% water content. The table shows the main properties of the binder, such as bituminous emulsion and cement. For the optimization of the water and the cement and bituminous emulsion content, we have used a laboratory protocol because, as I said in the first slides, do not exist the standard procedures in the literature for optimization of cold recycling of the asphalt mixtures. On the contrary, for the hot asphalt mixtures, the procedure is very robust and well structured. So, firstly, we have optimized the water plus cement content, specifically water percentage content from 3 to 7% by the total weight of the aggregates were investigated, combined with 4% of cement from 0.25% to 1% by the total weight of the aggregates. So we have investigated 20 combination of water plus cement values. The materials are characterized by different mixture contents. So we have preheated the limestone aggregate, jet grouting waste, and wrap. The blend was then mixed in a planetary for 50 minutes around, and then compacted by using a gyratory compactor. So we have identified the optimum content of the cement and the water when the mixtures reach a final bulk density not so far from value obtained for traditional hot-mix asphalt. So we have identified in 5% of the water and 0.5% of cement the best combination. Then we have added the bituminous emulsion, and we have added the best optimum content of water and cement. We have preheated, of course, bituminous emulsion, and we have identified in 5% of overstabilized bituminous emulsion the optimum bitumen emulsion content, because the bulk density is not so far from the bulk density observed for traditional hot-mix asphalt. Next step, focus on mechanical performance evaluation of these mixtures. In particular, we have identified indirect tensile stress. That is the common static test that we carry out on asphalt mixtures, called and hot asphalt mixtures, in dry and wet conditions. In particular, we have prepared 3 specimens under dry conditions and 6 under wet conditions. The specimens were prepared, as I said before, using a gyratory compaction. The test under dry condition was carried out at 25 Celsius degree after stored the specimen at this temperature for 4 hours in air chamber. At the same time, to evaluate the ATS in dry condition, we have kept the specimen before testing them in a water bath at 40 degrees for 72 hours. Then we have investigated the complex modulus by evaluating indirect tensile stiffness modulus according to international European procedures. In particular, we have investigated the stiffness modulus at 10, 25, 5 Celsius degree and 40 degree, because this temperature match the operative temperatures that we have inside during summer and during other seasons. In particular, we have to accelerate the curing process of the cold recycling of the mixtures at 40 Celsius degree for 72 hours, because we need to reach the full curing of the specimen. Final step, focus on evaluation on resistance to permanent deformation. In particular, we have used a cyclic compression test with confinement and the 2 specimens we prepared for each mixtures. The test was carried out at 40 Celsius degree. With regard to the cold recycling asphalt mixtures, the specimens were previously conditioned for 72 hours at test temperature beforehand. Few conclusions about that. Looking at the cold recycling of old asphalt mixtures in terms of indirect tensile stress, it can be observed in the graph that the cold recycling asphalt mixtures reach the ITS value of the traditional hot mix asphalt after 14 days of the curing time in dry conditions, but it reached the ATS of innovative hot mix asphalt that contains jet grouting waste in dry conditions over 28 days. It should be noted that increases in ITS for cold recycling mixture don't have a constant curing intervals. In fact, from 5 to 10 days and from 10 to 14 days, the ITS increase a lot, almost around 20% and around 5% on the last steps. Summing up the ITS for all mixtures, we can see that under dry conditions, in the red color in the graph, the innovative hot asphalt mixture shows a mean value ITS 10% almost higher than the observed value for the examined traditional hot mix asphalt, and almost 13% higher under wet conditions than traditional ones. With reference to cold recycling of asphalt mixtures containing jet grouting waste at 28 days of curing time, because I said that this is the time where we have observed the maximum curing effect. at the maximum performance of the cold recycling of the old asphalt mixtures with jet grouting waste, we see that on the one hand, we have high ITS value, of course, on dry and wet condition, close to the Italian standard when we have to reuse cold milled recycled asphalt pavement. On the other hand, we can observe that the higher mean ITS was reached for hot asphalt mixtures reusing jet grouting waste, but the value is very close to that observed for cold recycling at 28 days. The results show it that the mixtures don't have water sensibility because the ITS in dry and wet conditions it's not so far each other's for each mixtures. About stiffness, we can see, for example, that at 30 Celsius degree, the stiffness modules for cold recycling or asphalt mixtures change by curing time, but the maximum variation can be observed in the first 14 days. After the 14th day, the change is almost constant because of course, the reason this change is, of course, related to the water evaporation that affect the reduction of the water volume and a sharp increase of airway content, the breaking of the emulsion and the cement hydration. Regarding the stiffness modulus of all mixtures, the maximum value is reached, as I said, for the hot recycling of jet grouting waste. In particular, we can see that maximum value is reached, of course, when the temperature reduced, but the gap between values for traditional hot mix asphalt and hot mix asphalt using jet grouting waste or cold recycling of old milled asphalt mixture with jet grouting waste occurred at 28th day, reduced at 40 degree, and this is important. For us. So in terms of triaxial compression test to evaluate the deformation, we can see that the hot mix asphalt with jet grouting waste gives the lowest cumulative strain value, of course, that is reduced by almost 50% for hot mix asphalt containing jet grouting waste than traditional hot mix asphalt, and almost 30% for cold recycling of old milled with jet grouting waste than traditional one. Of course, the value of cold recycling of old milled asphalt with jet grouting waste referred to the 28 days of the curing time. So I just want to say that these alternative materials, jet grouting waste and RAP, can be used into pavements, in particular for making base layer of hot and cold mixtures, because they return a good final performance, both carrying out static and dynamic tests. Static tests in laboratories such as under direct tensile threat, dynamic tests like stiffness modulus, creep test. Of course, we need to carry out other types of tests, for example, rutting resistance, fatting resistance, and we need to carry out a life cycle assessment procedure, of course, of course, and compare these values with other type of niches where other type of waste can be reused. But the results are very good, and we are very confident with this type of with these improvements that we can reach in few time. So I thank you all, and we can see my mail, the link of the laboratory, the link of my department, and feel free to contact me for everything, for any questions to have, of course. So I've finished. Thank you, Potala. I don't know if I have to respect my time. If you have
Yes,
questions.
yes,